Good morning, everyone. Welcome to the first AWS Big Data Mini-Con. You know, I've spent most of my day yesterday talking with customers about the problems they're working on, how they're using our technology. It's actually one of the highlights about visiting at reInvent. I always learn something new. I'm always very impressed at what our customers are doing on top of AWS. But I'm also struck with the realization that for big data, it really is still day one for most companies, in particular mainstream enterprises. And I suspect that's why many of you are here today, is to learn more about big data. So we have an exciting day planned for you today. We're going to start today, however, by level setting, knowing that many of you are coming here to learn about big data, learn about what AWS offers in big data. So we're going to spend some time sharing with you how we think about big data, the key services that we build and operate for big data, and what their trajectory are. We're going to talk about some common use cases and questions that come up and kind of diffuse those and share with you how we think and what we see as patterns that customers are adopting for dealing with big data and some of the change in their thinking. And then we're going to include some new stuff as well, an announcement, a demonstration, and I've got a guest speaker who's going to join me, Richard Freeman, who's going to talk about how his company and he have actually used our services to actually build a big data solution on top of AWS. Now, after this morning talk, there are 4 parallel sessions, 3 of which are technical presentations, 4 hour-long talks that dive deep into many of the services and many of the techniques that I'll be discussing in my opening talk. I'll actually make some call-outs for those, but each one of them has been selected to go deeper into these topics. And in addition, there's a 4th parallel session which is a workshop as well. So you have many choices to fill out your day today. And I'm looking forward to many of these talks myself. Now, I'm going to avoid introducing yet another definition for big data, a 5th or 4th V, but instead talk about what it really means to you. And big data, because of the volume, because of the variety of data, it really forces you to innovate and make changes in how you collect, how you store, process, and analyze and share data. Simply put, the old methods simply no longer work. They don't scale. At AWS, we're innovating to try to provide you with the tools, the techniques, the technologies that will enable you to productively work with data at any scale. Here's a sample of select services in big data that AWS offers. And we'll move through these left to right. We have AWS Direct Connect, which allows you to connect a 1 gigabit and a 10 gigabit Ethernet from your company to AWS so that you can move data, you can take advantage of compute. We have AWS ImportExport that can move massive volumes of data into AWS, as well as Amazon Kinesis that allows you to move streaming data from continually generated devices and sensors into AWS, where you can store it in an array of storage services such as Amazon S3, DynamoDB. You can move it into analytics services such as Amazon EMR, Amazon Redshift. Should you want to back up your data, you can back it up into Glacier for less than a penny per gigabyte per month for archival purposes. Should you want to move your databases from on-prem, either one time or continuously replicating it, you can use AWS Data Migration Service to move your data to Aurora or to Amazon RDS as well. And you can set up AWS Data Pipeline to automate and schedule your big data processing workloads. Simply put, as files land in AWS every day, a pipeline can kick off to process them and load your analytics servers so when you come in at 9 in the morning, the reports are ready for you to look at. In 2016 alone, we introduced 1,000 new service features, new service improvements, and new services. The pace of innovation in AWS is blistering. And in fact, 2 of the services listed up on that chart were just introduced in the last few months. Amazon Quick Site, Amazon Kinesis Analytics, and I can guarantee you that after the keynotes tomorrow and on Thursday, we'll be completely reworking these slides because the family of big data services is in fact growing. And all of these services are available to you with a few mouse clicks. So let's go ahead and look at a few select ones that I want to make sure you understand how we perceive their role. Arguably, the foundation for big data on AWS is S3. It is an object store where you can store virtually any kind of data on AWS, from ordinary flat files to binary objects ranging from video, images, seismograms, you name it, you can store it on AWS S3. And it's extremely low cost, 25 cents per gigabyte per month. And it's, from the customer point of view, it is effectively infinitely scalable. There's no limit to what you can store into S3. We're going to come back onto this later because it is a key point. And more importantly, once data has been put into S3, it's accessible by virtually every single service on AWS has access to that data. And again, we're going to come back to that as an architectural best practice for actually building big data on AWS. We launched S3 back in 2006. At the time, it was an innovative pay-as-you-go model, the first of its kind, charging 15 cents per gigabyte per month. Over the last 10 years, we've made a series of price reductions. The most recent was just a couple of weeks ago. We've effectively brought the price of this storage down by 80%. And at the same time, the team's been introducing a number of customer-driven features, such as VPCE support, IPv6, website hosting, cross-region replication. The team also observed, our business observed, customers really, in many cases, were using S3 to store backup data. They didn't want to lose the data if something happened on-prem. So we released a new storage service called Glacier, which allows you to back up your data for indefinitely. And almost all the data you could ever imagine can be backed up for less than a penny per gigabyte per month. And just last year, the team realized also that there's an interesting use case. Customers wanted the same durability guarantees that you can get and reliability guarantees that you can get with S3, but that data doesn't get touched very often, so they introduced infrequently accessed as yet another new storage tier. And you can write lifecycle policy rules that will migrate your data from hot, actively used in S3. You notice that it's not being used, you can migrate it to infrequently accessed. It hasn't been touched for several weeks. Go ahead and move it off to Glacier and back and forth. So it gives you a lot of flexibility. And it's that last number, 11 nines of durability. We'll come back to why that's important in terms of allowing you to attach multiple applications to it. But this is the foundation, and we'll talk about the role it plays architecturally. Well, we also heard from our customers, we love S3, we've started using S3, but we have hundreds of terabytes, petabytes of data that we want to move to AWS. Last year we released AWS ImportExport Snowball. I just call it Snowball. It's a petabyte scale transfer service that uses our hardware, our network attached storage device. And this just isn't any network attached storage device. This thing can withstand 30 Gs of impact. I don't care how rough your transport or your carrier is, your Snowball is going to make it just fine when it gets into us. When you go to the AWS console to actually request a Snowball, an e-ink label on the Snowball gets generated with your address. Once it arrives, it has 50 and 80 terabyte capacity. You can order multiple of these and have them shipped to your facility. It comes with a 10 gigabit per second network interface and a cable to plug into your storage on-prem. As soon as it's full, the e-ink label changes back to the region, to the address for the region in which you want your data to be uploaded, and it can be picked up by the carrier, sent back to AWS, and within a day, we'll have it uploaded and accessible for you on AWS. And this is how we're allowing large companies to go ahead and move onto the cloud. And that data, encrypted with 256-bit encryption, nothing is going to happen to it. Even if it got misdirected, stolen, or whatever bad things you might think happened to it, your data is simply secure. Nothing's going to happen. By the way, we have a number of customers doing so many interesting use cases. They're taking these out on ships. They're taking these out in oil drilling rigs where they have no network connectivity, capturing all the data that they need and sending it back for upload and analysis. So it really opens up a wide variety of use cases. And it's okay, we've got our data up on AWS. You know, if you're doing structured data processing, Amazon Redshift is a petabyte scale data warehouse. It's simple, it's cost effective, no upfront commitment. You can actually start for as little as 25 cents an hour, going up to basically $1,000 per terabyte per year. And again, capacity up to 1 full petabyte, fully managed. It's highly integrated with a number of services and app and products, such as Tableau for visualizing data, such as machine learning toolkits for learning over the data, such as R for data scientists to explore. So we go, in a best practice, we're going to hit on this a couple times, is to store the raw data into S3. If you want to actually do some analysis, pull it up into Redshift, and then you have your familiar tools that you're already used to using to actually look at the data, slice and dice it, and then drop it out of Redshift. Going a little bit further, Amazon Elastic MapReduce. It is Hadoop as a service. You have the full Apache ecosystem available to you within 30 days of the time that the community makes a new drop. That is available in EMR. Another interesting thing is that it uses S3 as a data store for HBase. HBase is open source software that basically has very good performance for random access reads and writes over very large distributed data sets. And what this effectively does, and it's kind of subtle if you haven't looked at this, it decouples your compute from your storage. In typical Hadoop distributions, you buy a Hadoop cluster. Should you need to have multiple terabytes, hundreds of terabytes, you have to buy the corresponding cluster size so you get the compute that comes with that, even though you may not want it. By decoupling it like this, you can actually have your Hadoop cluster just the right size for the analytics that you want to process, whereas you may have a huge data store on S3. You get to pick and choose what you want to analyze with EMR at any given point in time. So this decoupling is for the customer advantage of allowing you to pick and choose for all the data that you have in S3 exactly what you want to apply EMR for. Again, going back to best practices and how these services work well together, it's a very common pattern. Because we have no schema applied to the data, it's an object store in S3, customers will use EMR when they have an analysis question they want to ask to run large MapReduce jobs, reading data from S3, applying the transforming and format, loading it to Redshift, and within a few minutes they can be analyzing with BI tooling in Redshift, and again, just drop it. So again, using our services for what they're best for. They're intended to be composed together like Lego blocks. What if we want log data? What if you're capturing log data from application servers for customer interactions? What if you're putting documents you want to actually analyze instantly, log records from app servers, feedback from your customers? This is where Amazon Elasticsearch comes in. It's a distributed search engine and analytics engine, and you can go from raw data to actionable insights within minutes. It's highly available, highly reliable. There's zero admin for our customers. Once the data is loaded, it's a fully managed Elasticsearch. It actually is tightly integrated with other AWS services, such as Kinesis, such as Lambda, as well as third parties, such as Elasticsearch and Kibana, to go end-to-end from raw log records into a loaded Elasticsearch cluster. And again, it has reverse indexing, so if you wanted to find all the documents in your collection that had certain keywords, it's been indexed, reverse indexed immediately once it's loaded, and so you can immediately find all documents that have certain keywords in it. So again, for these semi-structured use cases and unstructured, this service plays a very valuable role for big data. Serverless, Lambda. This has actually really turned things upside down. Because what if you actually just want to have your code executed in response to an event, and you don't want to manage EC2 instances, you don't want to manage servers? You can actually give the code in Python, Java, and JavaScript to Lambda, and we'll do the management and execution for it. And you're only charged for the time your code is actually executed by a customer in response to some event at a granularity of 100 milliseconds. Nobody's calling your code, zero bill, it just quiesces and goes quiet. You get slashdotted or somebody puts out an article and it gets highly popular, we scale it on your behalf to ensure that the requests are handled, and we do fault tolerance to fail over as well in case one of the instances behind the scenes has issues. So again, if you want to roll your own analytics and roll your own code but not manage servers, AWS Lambda is an incredibly powerful service, and it actually allows us to extend each one of our AWS services, and I'll talk about that in a second. Then there's Amazon Kinesis. What if your data is continuously generated off of devices, off of sensors, and you want to have real-time insights into that data? This is where Kinesis comes into play. Kinesis is Amazon's data streaming platform. There's actually 3 services today which make up Kinesis. The first, launched in 2013, allows you to stream hundreds of terabytes per hour to AWS into a stream. We provide a Kinesis client library that you can actually use in Java, in Python, and Go, and actually write a distributed application to process this data and build your own custom applications. If you want to use something like Redshift or Lambda or Storm, Spark Streaming, we have connectors to those as well, so you can actually do your processing of your streaming of the data coming in through a Kinesis stream. But we noticed after 2013, most of our customers were actually taking advantage of existing services like Redshift and looking at the data in Tableau. They were trying to load it into Elasticsearch. They were trying to load it into S3 for all the good reasons we've talked about. So in 2015, we released Kinesis Firehose. Again, it's serverless. You don't have to provision anything. You create a delivery stream. You don't have to worry about how to scale it. You tell us the destination you want the data to appear in, and how many seconds or how many minutes should it be encrypted, compressed. You install agents on-prem where your servers are generating the data, and within minutes, that data is streamed up into these destinations that you've selected with this service. And again, for users who don't want to write their own custom event processing or stream processing, they can take advantage of Firehose and use the servers that they've already used, but guess what? They've moved into the real-time world. We've got some wonderful success stories that are coming out, documented customer use cases of customers who only got to see their sales data at the end of their anniversary sale or every week. And now they're getting it hourly because they're using Firehose to load the services that they were already using for AWS. What we released earlier this year was Kinesis Analytics, because the next request we heard from customers is, wow, I'd really like to actually not write an app to manage or process my streaming data. I'd actually like to give you my code. In particular, I'd like to give you SQL and have you run SQL over the streaming data and actually produce the output. Kinesis Analytics is a fully managed service that takes ANSI standard SQL, and as your data is streaming by, it executes these queries continuously with low latency to produce an output stream of the processed data. Nothing to manage. It's pay-as-you-go. We fully scale it depending on the demand of the data coming in or the number of queries you're trying to process. No data, no queries, we quiesce it down to nothing. And so, again, pay-as-you-go. We manage the variability and the scaling of this. We've also been hearing recently from customers that were using Firehose, you know, I love Firehose. I'm trying to put the data into Elasticsearch or to Redshift. I'm reading it from S3 or I'm reading it off of a device, and I need to format it. I need to enrich it. I need to clean it before I load it into these destination services. So I'm extremely pleased to pre-announce that in the next couple of weeks, we're releasing inline processing into Kinesis Firehose, where you can write any arbitrary Lambda function as every record is streaming by through the Firehose. We're going to apply the Lambda function, shape it, clean it, format it, and deliver it onto its destination. In addition, we're going to provide a library of ready-to-use templates for the common data transformations we see our customers using, and we'll continue to build that out. So now you can go end-to-end from raw data to loading into Elasticsearch or to Redshift, and all your logic of cleaning and shaping can take place there. And then finally, another new service that was released this year is Quick Site. It is for your business analysts who want to slice and dice the data, go data mining and exploring, share it with anybody in the company, share it on the web, share it in mobile at 1/10 the cost of traditional BI solutions. And if you look at the connectivity, it's pretty much where you're going to find most of your business data from Excel, of course Amazon S3, Redshift, MySQL, Oracle, RDS, Salesforce, etc. So if you have data in these sources, you'll be able to connect with Quick Site and in a few minutes have your BI professionals slicing and dicing and actually getting insights into the data, and then being able to share that. Okay, now let's start putting these together. I think these are some building blocks that I want to make sure you're aware of, and I hope you'll dive deeper in each one of them. But I want to talk about some conversations that we tend to have with customers. One of the first ones that comes up is scale. And it's actually not just a single question, it's actually a myriad of questions, ranging from how can I scale up with the volume of data being generated? Am I going to make a bad choice? How can I collect data quickly from various sources? One of their woes is currently in enterprises, they're looking at silos. They have 5, 6, 7 different data sources where data is in, and if you need to move it from one to the other, it becomes an arduous task. Another question we see is, okay, now I've got it into the cloud. How can I ensure my entire company can actually run concurrently analytics against it? And indeed, I was talking to an enterprise customer yesterday, and they're explaining about how they do it on-prem, where they will replicate the data when they know 2 or 3 people are going to run the same kind of analysis against it, because they're worried about contention. I want to hit that point. There is a pattern that is emerging, and it's resonating with the community, and it's working for people, and that is to treat S3 as your data lake. It's infinitely scalable. It can handle future data growth. You will never have to worry about Amazon's scale ever becoming an impedance. It's incredibly flexible in all of the tools. As I mentioned earlier, all AWS services attach to S3, so any tool can immediately access it. You can store anything and everything in one place in S3 at extremely low cost. At the beginning of that slide, you saw S3 and all the 11 nines of data durability. Anybody who's thought or worked in databases realize you get that kind of high data durability by having multiple copies and a bunch of other techniques working behind the scenes to ensure that we can give you that data durability. Amazon S3 uses this intelligently such that if you have multiple applications trying to simultaneously read from the same data set, we will distribute those reads across all of these multiple copies. This is a real mind change for people. They realize I don't have to worry about contention and I don't have my people to have to resource schedule. We can instead have multiple applications actually pointing to S3 and reading from it. And this is really also about schema comes on read. When you write the data, you write it raw. And this is actually a diagram I like to share because for those of us who have been building data management systems in the past, this is a little striking. In the center is S3. This is the raw, unformatted data. On the left, you see all the data ingest services we've talked about. On the right, you see various services that can attach, analyze, as well at the top, we have catalogs, we have access and user interfaces. This is the mental model that most major companies that have been working with big data are snapping to, that S3 is the data lake. Put all of your data into it. Any one of your customers in your enterprise can choose the application that they're most comfortable with, and they can go in and read from the data lake. And this also represents one of the more interesting mind shifts that's happened in big data. 5, 7, 10 years ago, we operated in an era of scarcity. We always thought about what kind of analysis do we need to do, what kind of schemas should we do, how do we format the data, how to build the ETL pipeline. We live in a world of abundance where we can literally store everything at incredibly low cost on S3, and of course we can tier the storage. Because of the sole belief that there may be latent value in our data, we might be able to extract 2 or 3 years later, so don't touch it. Put it in S3, lifecycle policies to move it out into other tiered storage, but you never want to be without that raw data because you might be something valuable in it. Another aspect of scale and agility, which I love to share with people, is how fast can you actually scale your analytics? Well, you can get a new BI server from the Amazon console basically within 20 minutes and have it loaded with data. You can add 50 terabytes of storage to your Redshift instantly, whereas that would take an enterprise IT department about 2 months. You can grow your data warehouse cluster from 8 gigabytes to 1 petabyte in an hour. You can build a 1,024 node Hadoop cluster in about 30 minutes on EMR. You can only imagine what it would take a traditional IT company to order the necessary hardware to rack and stack and get that thing tuned. And should your business explode and you want to go multi-regional, you can do that in a few hours and basically deploy your services around the world in all of the regions in which AWS operates. That's also part of the value prop of scale. Now, Netflix needs no introduction into their clever use of data, their innovative practices, and how they've run their business and made the most out of data. I would strongly encourage you. They're presenting Netflix using Amazon S3 as the fabric of our big data ecosystem, talking about much of what I've just shared with you. They'll be going deeper. Their talks today at 5:30 in Mirage, this building, St. Croix B. They'll take you on a deeper dive on this story. And if you're interested in this, I'd strongly encourage you to attend. Let's talk about cost briefly also, because that's another thing that people question about. Let's use a simple example. What if we wanted to process the entire Twitter firehose, maybe do sentiment analytics, monitor politicians, do a number of things. There's a number of my customers who do this. They actually track their brands, they track sentiment, they actually track how things are trending. And so let's imagine we wanted to put a service together that would actually ingest the entire Twitter firehose into Kinesis. We'd write some Kinesis-enabled applications on EC2. We'd archive our data in S3, which then we could load into Redshift and put a Tableau or any other interface in front of it, so we could actually watch trending topics and see what are the hot tweets. We might even want to archive that to Glacier. If you put some prices on it, the first thing you notice is that we're looking about everything in the pennies per hour to do this end-to-end. Well, what if we actually wanted to process the full Twitter firehose and track what's going on out in the world? Let's look at the numbers. Twitter firehose, about 500 million tweets per day. That's about 5,800 tweets per second. These tweets are about 2K, so that's about 12 megabytes per second. All total, you're going to ingest a terabyte a day. In Kinesis speak, you're going to need a 12 shard stream, We'll throw in a couple more, 14, just to make it safe for growth. And so it's $0.015 per hour to reserve a shard in a stream, and about 1.4 pennies per million puts into your stream. So your whole Amazon Kinesis cost per hour is 47 cents. Putting it into Amazon Redshift so we can then display it and look at it is 85 cents an hour, assuming we're going to maintain about 2 terabytes of historical data. The S3 cost for archival purposes, $1 an hour. The total cost for running an application like this, ingesting and processing the whole Twitter files, is on $2.34 an hour. This is the beauty about being able to use only the services you need, you scale only the services you need, you pay for what you use, and what I've shown you are just the flat rates. You can actually get discounts through reserved instances, spot instances, and upfront commitments. So cost here just simply doesn't become a factor for many of these jobs. What about scale and security? This is also another concern. Customers come up and talk to me and they say, hey, we love the services. We've written some prototypes. We work in highly regulated industries. Our data is very valuable to us, so we're a little bit concerned about what we should do. FINRA. FINRA has been doing big data before many of us even were using that word on a regular basis. FINRA monitors all of the financial transactions. At present, that's 75 billion market events per day for NASDAQ, New York Stock Exchange. And what they're doing is they're trying to deter misconduct by enforcing rules. They have to detect wrongdoing. They have to discipline those who break rules. And this is a highly secure service or an environment to operate in, highly regulated, highly adversarial, and it's constantly evolving. Not only are the threats changing, but the rules on which they have to operate are changing, the exchanges are changing, so they have to have a highly fluid environment again, yet be highly secure. A little illustration, they will be giving a talk later today. On the left, they're treating S3 as their data lake for all New York Stock Exchange data, all NASDAQ, all direct exchange, go into Amazon S3 as their data lake. They ingest petabytes, we'll leave it at that, of data from on-prem and bring it into AWS every day. Thousands of analytical queries. They actually have 400 analytical packages which are running on Amazon Redshift and EMR, analyzing all the transactions that are going through each and every day. This is incredible skill, and they have incredibly stringent requirements. They're leveraging VPCE. They have flow logs that show them each and every transaction that has gone through. They use encryption at rest for all of their data. AWS CloudTrail and database auditing can show them exactly who's given them access to everything so that they can meet all the security requirements. We have a number of such customers that work in these industries, and I'll talk about that a little bit later, just by naming a few. What I would like to give a shout out, FINRA is giving a talk later today, 4 o'clock, here in this building again, St. Croix B. But they're able to talk about how they store exabytes of data or more in S3, analyze gigabytes to petabytes every day using standard services. They're doing encryption. They have auditability of all of their APIs. And they can control egress and ingress points using VPC to ensure exactly who has access to the service. Well, what about agility and actionable insights? We're talking real time here because as you're starting to become aware, maybe reading more, data is continuously generated. How could we actually turn that into actionable insights? So I want to do something a little fun here. For those of you with mobile phones, Android or iPhone, I would like to ask that you point your Chrome or browser or whatever at this URL. You won't be installing anything on your phone. And what you're going to see here are those 4 images that I'm displaying there. Once you hit that URL, http amazon.to/big data. And there's actually 4 quadrants, and what they represent in the upper left-hand quadrant, it's new Amazon Web Services. On the right-hand side, it's the blackjack game that's coming up. Left-hand corner, lower left, networking with your peers. And lower right, the replay party. And you can actually use your accelerometer to actually roll your phone around a little bit. Let's go ahead and actually go over to the other screen, please. Other computer. There we go. So what you're seeing here, guys, is, we've jumped up. We've got about 300 people playing along. We're actually sending these events up to the cloud, up to Kinesis, and actually doing real-time analytics up to 400. We see that we've got predominantly iPhones here, a few Androids, a few other, and the numbers going. Now let me ask a question. The first question I want to ask, just to get my notes up, what item most interests you this week? Go ahead and hover the ball over what most interests you this week. What are you most interested in learning about this week? Go ahead and just let that ball hover over there for a few minutes. New services. And you see the shift taking place. Very cool. Within a second. Okay, what will your colleagues be most interested in hearing about when you return next week? Yeah, the blackjack's picking up the party. Services are holding their own, though. You know it's going to be a fun party. Come on. There we go. I look forward to seeing you at blackjack. Last little question, just to interact here. What would give you the biggest headache this week? What do you anticipate is going to give you the biggest headache? Yeah. If history proves correct, I'm with you guys. And again, we can actually see participation dropped off, spiked back up. All right, thank you. Let's go back over to the other monitor, please. You know, the thing about this is, you were just actually hitting a web page, but imagine if that was embedded in a device, in a vehicle that you were monitoring. What if it was in a service that you're monitoring and you had hundreds of thousands of services? What if this was actually a customer engagement that you're tracking? You have this ability to have real-time insights into your customer, into your business, and if you can actually monitor it, you can own it, and you can react in real time. That demo architecture, guys, we're using Amazon Cognito to give you a unique identifier for the session. That data that from your app was going into the Kinesis ingestion stream, Kinesis Analytics, a simple SQL query. I'll actually show you the whole code behind this thing. The output of that Kinesis Analytics fed a Kinesis aggregate stream. A Lambda function cleaned it and shaped it for us. We loaded Dynamo. We uploaded the icons from S3, and we built that little dashboard. The demo was built with all about that much code. There's the entire SQL. And that entire app was serverless. I did not provision a single instance, EC2 instance, and if we had have actually opened this up to several more rooms, the service would have simply scaled with it as well. You have the ability to monitor hundreds of thousands of devices. So, big data does not have to mean just batch. It can be streamed in, processed in real time, and you can respond to requests and actionable insights to generate business value. And you can mix and match. You could have used any Lambda or KCL and have written your own app to do all this analytics. It doesn't just have to be our services, but this is what it offers you. Let me just close on this about choice and selection, because I've talked a lot about AWS services. But the reality is we have over 2,000 product listings in the AWS Marketplace. All of these are provisioned within a few mouse clicks, same business model, pay as you go, no commitments whatsoever. Over 290 of the offerings in the marketplace are specific to big data. A success story that I like to share, a data scientist working at Philips had a business question. He had over 36,000 million rows he had to analyze. He got an estimate from his team that it was going to take 3 months to actually implement the solution. On a Saturday evening, he found an application in the marketplace. Within 1 hour, his job was done. And this is the opportunity you have. It's not just our services, it's any service that's available to the marketplace. We actually have one of the largest ecosystems of ISVs and integrators as well, of any cloud offering, tens of thousands of companies that offer a wide range of products and services. Because really, we have a retail mindset. We build what we think our customers need. We welcome others to come in and put their offerings in the marketplace. You can use ours, you can build your own, you can access thousands in the marketplace. Customers decide for themselves. So at this point, I would like to invite Dr. Richard Freeman. He's lead data engineer and solution architect working out of London for the Tech for Good company, Just Giving.
Okay, so that's right. Yep. Hello, everybody. So it's great today to be here, especially as it's Giving Tuesday. So we had the Black Friday on Friday, now it's a Giving Tuesday, where a lot of people actually donating their time or money for good causes. So today, I'm going to be talking about our big data platform at Just Giving. Just a bit of background on the company. So we are a Tech for Good company. We work in the charity sector, as well as crowdfunding projects for good and special charities also. We are the #1 platform for online social giving in the world, and this is based on our 28.5 million users who have transacted on the platform, as well as our presence in 196 countries and having a total set of 27,000 charities, as well as crowdfunding projects for good. So we're #1, and we've actually raised 4.2 billion in donations since the creation of the company. So yeah, that's a huge amount of money if you think about it, $4.2 billion going towards good causes. And how we like to deal with it is to ensure that no good cause goes unfunded. In order to do that, we actually try and understand our users better. And to actually understand them better, we found that we need to provide engaging content. So this is content that they are very interested in. So this could be via mail, or it could be via our feed product. And we found that actually, to understand why someone donates time, why someone runs for a marathon to raise for a charity, there are lots of different reasons. We found that understanding the relationship between the users and the charity is really important. The best way we have found to do that is actually to create a graph representation of all of that. We called it the Give Graph, and it contains 500 million nodes. 500 million relationships and about 100 million nodes. So you could think of a node as either an individual, a colleague who sponsored that individual, a crowdfunding page for good causes, a specific charity. If it's a charity, you can actually decompose those into a type of charity. For example, if it's an animal charity, you can break it down into dog charities in a specific location, for example, in Las Vegas. And we create that huge graph, and this is actually one of the biggest world giving graphs that exist. We also take some of the connections amongst Facebook for that graph. We've also been using AWS in production for a number of years, and it helps us scale out very easily in terms of peaks traffics. So think about in the past, the ice bucket challenge, where many people, in order to raise money, put an ice bucket on their head, and that led to lots of spikes in our website and mobile app. So we used AWS to again scale out very quickly and have that working. So this is one of our products. This is a fundraising page, just to give you a bit more context around the data capture. So this is actually, you can see at the top, this is for a running marathon. And how it works is a person wants to raise money for a charity. They create a fundraising page. They set a specific target based on the amount they think they can raise. And then they would send out an email address, an email to their colleagues, to their friends and family, in order to try and raise that amount. There's also the integration with Facebook and Twitter, the social feed. And the user also provides updates. So depending on, so if this is a half marathon, for example, Sophie will be, in this case, practicing running in advance and provide updates on how everything's going. Under the hood, we have a lot of product that actually supports this fundraising page. So, for example, the fundraising page target, we're actually using all the data we know about Sophie, her past transactions on Just Giving, how she interacts with the website, to actually make a recommendation on how much we think she can actually raise. We also use data science to actually provide insight into how Sophie can actually raise more money in creating a perfect page. At the same time, we're capturing a lot of the data. So this is the clickstream data, how users actually view the page, how users actually click on share, for example, on Facebook. And that helps us understand the actual behavior of the user. So there's also a set of updates and messages so you can actually respond. So it's a very social interaction. Giving is very personal. It is a network of relationships. So this could be colleagues, friends, family, or some specific crowdfunding project. So something you're raising, for example, if one of your colleagues has some issues, you want to raise money for them specifically. So about 3 years ago, we introduced data science almost into JustGiving. And we found that our existing data warehouse wasn't able to cope with the complexity of the queries. We were also bringing in more and more data, so our SQL Server just wasn't able to cope. And in fact, what happened is our data science queries were so long, they took tens of hours, and they used to get canceled by the database teams. So we had to sneakily put them in at 6 p.m. After they went home. So think about long-running queries and complex queries that are running in terms of data science, in terms of machine learning, in terms of graph analytics. That was one of the key requirements that we had. In addition to new data sources. So I've talked about the clickstream data and user behavioral data. There's other data sources that we're very interested, such as the Twitter data feed, as well as exact target, which is our mailer, so how we send out an email, and other integration like SurveyMonkey or news feeds. In addition, we have a requirement for log data, so think about the web analytics data that comes in via the logs, the server logs. So that's a lot more data coming in, so the data warehouse definitely couldn't cope with that. We also wanted an easy way to actually add new data sources. So all these data sources, we wanted a very quick way where we could release an integration, ingest the data, process it through a pipeline. At the bottom, you can see a simplified version of our automated pipeline. It takes in data. We load the data, always ends up in S3. We prepare the data, we transform it, make it available, and then we run our machine learning, graph processing, natural language processing, and streaming analytics processes. I'll show you in the next slide a bit more detail around that. So this was sort of our requirements. At the end, from a business point of view, a consumer of the data, we want to gain and measure in a data-driven way all of this data and try and understand, to gain insight from the data, as well as predict exactly the success. For example, we talked about the fundraising project page earlier. So we want to understand if we release a new feature, for example, the set of updates, then we want to understand if that is working. So this allows us to do A/B testing, for example, as well as predict the success of a new feature. In addition, we make recommendations to the user. So we talked about the recommended target value for the fundraising page. There's a lot of other recommendations we could recommend. Also, people you may know, a bit like you see on LinkedIn, you see level 1, 2, 3, 4. We can do that also. So I'm just going to briefly talk about the Raven platform, which stands for Reporting Analytics, Visualization, Experimental Networks. So this is a platform that we've built in-house using the AWS managed services. And it is using event-driven architecture and serverless pipelines. So Roger talked about a bit more of the serverless concepts, so we'll briefly cover that in this session. Event-driven, if you think about it, maybe some of you amongst the crowd are familiar with enterprise service buses, queuing messaging technologies, publish, subscribe mechanisms. So these are typical patterns that you would use as a developer or as an architect. Traditionally, big data has been more about using workflows, ETL processes, directed acyclic graphs, which is DAGs there. But how we've approached the platform is actually event-driven. So we're actually sending events. As the data arrives, we load it, process it, and make it available to the rest, rather than draw up big workflows where any changes need to be propagated through. Any changes in tables on the input will need to be changed. We just load the events as they arrive. We process them very fast, and the data is simply available. It supports ETL, ELT at scale, machine learning, natural language processing, and graph processing. This is done using EMR and Spark, as well as the Lambda functions, which we'll cover very briefly in this session. Again, the idea, at the end of the result, all of this is done using the Raven platform, and the raw data is available, data blocks are available, which allows you to consume, for example, a unified view of the whole clickstream, transactional data, log data. I've got a diagram next which illustrates some of that. And at the same time, we're running our analytics, our metrics, in near real time, so we actually know what's happening. So this is an overview of the Raven platform at JustGiving. So you can see at the top left, we have Kissmetrics. Kissmetrics is essentially a client-side web analytics. Think of it as a Google Analytics, but more at user level, so you're actually understanding what the user clicks on. Whereas Google is typically used more as an aggregate, so you'd see page views, but you don't necessarily know who actually did that. We also make use of Kinesis streams. So this is on the server-side analytics. So we have microservices and microsites that actually send events in real time into there. We also have Logstash. So this is for the app logs and the web logs. And we're ingesting that also. We also use Qualaroo, which is like a mini survey, which pops up and tries to understand almost what you're doing within the context of the actions you're taking on the site or the mobile app. You can see on the middle left side, we have API integration. So this is just a subset of what we have. So we have SurveyMonkey for the largest surveys, which are triggered automatically. So we're bringing in the results of the survey. Exact Target, which is the mailing. So we send out specific mail shots via email to specific users based on some events. We also bring in Twitter data, as well as the newsfeed data and other open source data sets. You can see at the bottom on the left, we have facts and dimensions from our data warehouse that we also ingest, as well as the OLTP files. On the middle, you see we've got the ingestion layer, the integration between all the services, and this is where all the magic happens. Some of the machine learning, some of the ETL processes are actually done there, again, using an event-driven architecture for that. In the middle, you see we've got the data. So Roger talked about the data lake concept. So this is something I really like, I'm quite passionate about. So we're actually loading all the data, everything ends up in S3, and then gets loaded into Redshift or into an EMR, which stands for Elastic MapReduce cluster, to actually query data from S3. The beauty and how we see it is that the clusters are disposable. So if we need another cluster, we can spin up a Redshift cluster very easy at JustGiving, and then reload all the data, reprocess all the ETL. The master data almost is in S3. And on the right, so we have different tools to actually consume the data almost. So because, for example, Redshift is really open, you can connect via JDBC, ODBC, Postgres connections. You can actually use data science tools such as Python or R, very easy, SPSS, to actually connect there. And actually, I have the clean data set almost for consumption. And if you think about everything that we have on the left is effectively available. So you can actually join the web analytics data, server side, client side, all the logs with all the API data that we know about the users externally, as well as the data warehouse, the transactional data. So transactional data will be the fact that someone's donated at a specific time and the charity transactions. And if you think about joining all that data together, that's what we can do using this platform, which is really powerful, which gives you a full view of the actual user, again, to help us provide them with more engaging content. On the right, again, if we just continue, so we can connect using other tools. So for real-time analytics, we're using Lambda to actually consume the data straight from Kinesis streams. I'll show you next a brief peek on some of that. We also use Spark to actually consume and to run some of the further machine learning on the platform. So this is a sneak peek. I'm running a talk later on this afternoon at 2:30, and also, because that's full, I'm running another one tomorrow. I've got the details afterwards. This is a pattern that we came up to create a serverless streaming analytics pattern and a way of actually persisting those results permanently into S3 and loading it into subsequent systems. So you can see on the left, we talked about web analytics, for example. So imagine that your web analytics is getting loaded into Kinesis or into Dynamo Streams. That data gets passed using micro batches into a Lambda function. Lambda function then runs a set of counts. So imagine it's a fundraising page. we want to analyze a specific page views, for example, for that specific page. So we can do a set of counting. We can count impressions, clicks, maybe shares on Facebook. That data can get passed into CloudWatch Metrics, which is an Amazon service which is accessible on the console. So there's nothing to create. From there, you've got a real-time platform that actually you can see exactly the page views. The alternative, which is similar to what Roger talked about, is to actually also write those results, write all the counters into DynamoDB, and then what I've written is Charts.js using Node and JavaScript to actually read that data, almost read those page views in real time, chart them over time, and allow for real-time updates. Equally, you can have that displayed as a table, so you can see actual page views. And that allows us to, almost in a serverless way, present the data results. At the bottom, so we've got the new product, which is Kinesis Analytics, which allows you to write SQL on top of the stream of data. So this could do the page view counts again, push them to the Firehose. The Firehose will then push those results into S3 for actual loading into the subsequent Redshift or Spark. The outcome. So Amazon Kinesis has allowed us to ingest our full click stream, so from the whole site in real time into our platform, and allowed us to actually run real-time analytics queries. So we can actually understand down to the second almost what users are actually doing on the platform. And we've also talked about a pattern for actually persisting that, which is useful for persisting in long-term store in Redshift. So Raven platform has allowed us to, in an event-driven way, load data and process it in near real time. As the data arrives, we actually process it. And this is thanks to using the managed services in AWS, where we actually process, where there's actually not much to support. As a managed service, there's not much to do for Redshift, I'd say. You can resize it very easily. You can add more nodes. You can downsize it. It gets upgraded automatically. It's a great service. We also, as we talked about, the event-driven side. So we're using event-driven architecture as well as the serverless patterns. So this is something I recommend you should think about in your organization also. There's lots of benefits in not having a server running. So there's no box to remote onto, to fix, to apply a patch. So you don't need to maintain the operating system or even have a pipeline for maintaining containers. So serverless is a way you should really definitely look into also. And this is what we've been using extensively at JustGiving. Using managed services, again, we able to automatically run at scale, so scale out the number of queries, as well as compute really complex queries, again, in near real time, or as part of the batch processor that we're running in Redshift. Overall, it's improved the productivity considerably at JustGiving. So we allow our data scientists, rather than reinventing the wheel, cleansing all the data, doing a massive join every time, we actually have that already available for experimentation. They can take that data, run the A/B tests directly, run the machine learning models, try and understand the users, query our give graph directly. So this saves considerable amount of time. And it's something that often people talk about data science, they don't realize that maybe 80% of that is actually data preparation, preparing the data frames, ready for querying, cleansing the data, enriching the data. We've actually done that already, so our data scientists love it. And that's a really valuable thing in terms of resourcing. Again, the ultimate aim for the business is to provide more insight to what's happening on the site, provide insight to the actual users, measure the success of a product and how we release those features, as well as predict what are the new features we should release and what products also. As well as we talked about recommending, for example, recommending what is a perfect fundraising page. How can you achieve the perfect fundraising page to actually raise money for the cause that you really care about. So thank you very much for your attention. And I'd like to say that if you want to get more details, I'm going to drill into a lot more of this in terms of the serverless data pipelines, the event-driven ETL, and the stream processing. So there's a session later on this afternoon, as well as tomorrow, which is a repeat session. So thank you for your attention, and have a think about how you can use tech for good also. Thank you.
Thank you, sir. Thank you. Thank you, Richard. I was actually extremely pleased when Richard agreed to talk. Not only is his service incredibly interesting, but I love the application. It's a beautiful application of technology. Okay, that was one example. I just simply want to share with you, we have over 170 unique customer references for big data and analytics. We have some of the largest enterprise customers such as GE, Johnson & Johnson, and Philips. We have some of the most successful tech startups such as Airbnb and Pinterest, largest media companies such as Hearst and Netflix using AWS, as well as highly regulated organizations and agencies, FINRA, NASDAQ, NASA. So again, a lot of companies are making big bets, but it's still very early days on big data. Folks, I hope you enjoy the rest of the day here in the AWS Big Data Con. These are the talks that will be held here in this building throughout the rest of the day. If something has piqued your interest, please look at the agenda. I think you'll find a talk that will take you on a deeper dive of many of the stuff that we've just talked about. We also, and these slides will be available, we have resources should you want to actually get started on your own journey. That are available. I'll leave this up and simply thank you and actually encourage you to take the survey, give us some feedback, and enjoy the rest of reInvent and the Big Data Con. Thank you.